Howdy folks. Going to do a machinery autopsy video today. This is an Embraco compressor built in November of 2009. So it's over 10 years old, but not by much. This came from a real basic Whirlpool side-by-side fridge. The guy also has a 1940s GE that I worked on last year, and I let him talk me into working on his modern fridge, just you know, because you do that kind of thing for your friends. And the compressor is seized. Doesn't do anything other than hum. Now electrically, everything looks just fine. So I'm going to turn on the meter, and I'll show what I'm talking about. So the common is the top one. There's 3.1 and 6.0. So that 3.1 would be the run winding or main winding. 6 ohm higher resistance, that would be the start. So this should be the sum of the two, which it is, close enough. Then if I check the ground, there's no ground fault. So this is not a burnout. It did not have a winding failure. So and furthermore, he said that it was operating perfectly fine, hadn't had any indication of trouble. And then one day he came in and found all of his ice had melted, and he could hear the overload clicking every few minutes. So no warning and sudden failure. So I'm going to demonstrate the failure mode by trying to power it on, and then once I show the failure mode, we will cut the top off of it and see what actually happened. So the main winding was this pin, this side, and the start winding was this pin on the back side. Like that. And then I've got a RO81 start device, which this compressor came from the factory with a PTC start device anyway. So that's exactly what it was designed to operate with. And in case it decides it wants to show me up and start, I'm going to go ahead and take these caps off of it so they don't shoot off and hit me. So this is going to be a start attempt here. It has kind of a loose buzzing noise to it that's not normal. Usually if they're stuck from, you know, dried up oil or something from the lines being cut, you don't hear that loose buzzing noise. So that to me indicates some kind of mechanical failure. Now in an attempt to help just go through the motions again, I've already done this once. I'm going to connect the capacitor here in series with the start winding to give it more startup torque, and see if this will break it free. Make sure that's clipped on there. Now I've got to wait 5 minutes for this RO81 to cool down and reset for the start circuit to work again. So I'm going to cut off the camera and come back after about 5 minutes, and we'll make another start attempt. Alright, it's been about 5 minutes. Got the capacitor in the circuit, and we'll give it a couple of blips of power. Move this over here where I can reach it easier. So same thing. And that was with the capacitor trying to help it go. I'm not going to repeat this part that I'm about to explain, but when this was still in the refrigerator, I actually gave it 2 times its rated voltage with the capacitor to try and get it going, and that was not able to get it going. So I don't hold out any hope for this working again, and we're going to cut it open now and find out what went wrong. I'm going to pour out a little bit of oil from this compressor just to see what it looks like. I guess not from that port. See how kind of cloudy it looks? That's some kind of shavings in there. I'm reasonably sure. I'm going to shake the compressor up. Try to agitate that oil and pour a little more out. See if it's blacker. Yeah, you see that cloudy metallic look? Oh, and I think I heard pieces falling around inside the housing. Definitely a mechanical failure. So all I did was set it down on the floor and cut off the top with the grinder. And now it turns completely freely. I don't understand that at all. So I'm gonna put some power on it. We'll see if it'll run under its own power. I don't understand, because I didn't drop it, I didn't bump it, I set it, just calmly set it down on the ground and cut off the top. I didn't hit the mechanism with the grinder. Nothing odd happened. I don't understand. My guess is that it still won't start, and maybe I was wrong about the winding. Maybe there's something wrong with that winding where it's not able to produce torque anymore. Some kind of a internal short where the coils are working against each other. I just don't know. But we're going to try to power it on again. This is no capacitor, just normal hookup like it normally would have. So let's see what we get here. Nope. Oh yeah. I see what's happening now. The main bearing's gone. This whole thing, the rotor is kicking to the side in there. That does make sense. Wonder if there's a certain position where it'll start in. Nope. See, it locks up solid the minute I put power on it. Well, that's good. That makes me feel better that I didn't cut up a perfectly good compressor. So it turns easily, but it'll go side to side. Don't know how well the camera's going to pick that up. I'm trying to so that's causing a rub between the rotor and stator. And when you got a rub like that, that's a tremendous amount of friction. And once the magnets are on, the coils are on trying to start the motor, it will pull that rotor against the stator, pull the iron against the iron and lock it down. And I'm sure that there's rub marks on the inside of the stator and on the rotor. I'll take this apart and get a better look at the collateral damage. Yeah, I see the rub right down in here. Try to get it where the camera will pick it up. There's a little polished up area right in there. It didn't get it hot enough right there to ground out the compressor and cause it to ground fault, but it did lock it up. You can see right down in here, it's got a rub on it. So apparently what happened to this was, for whatever reason, the oil wasn't able to prevent wear from occurring in the main bearing. That's got looseness in it that it shouldn't have. So I went ahead and I pressed off the rotor to get that out of the way. And now this big end bearing, that's made out of a powdered metal, some kind of sintered powdered metal. And there was a clip on there, and that just broke when I tried to take the clip off, so it's really flimsy. There's the main shaft. There's the plastic cage bearing I was talking about. Sits on that race right there. Looks like there's a wave washer, probably to help support things if there's some kind of bounce, it won't hit on the bearing. If you look down here, that's all grooved. It's not worn much, but it's enough. If you look inside there, that bore is really grooved as well. If I put the thrust bearing back in place, it should ride in exactly the same position again. You can even see some wear on that upper thrust bearing race. Yep, definitely abnormal side-to-side play. So why did this happen? Obviously, with that type of damage, it was lubrication related. The oil film was interrupted for some reason down here, and it let the shaft and the bore for this main bearing wear. And this oil, and this is at room temperature. It's like water. So the reason that they would choose an oil that's like water like that is because, assuming it does lubricate, assuming the film is sufficient to keep the metal from touching metal on metal, there's very little energy required to circulate that oil and move it around the system. If you have an oil with a higher viscosity, then that oil is going to provide more drag on the machine and cause it to have a higher energy use. But it would also have a greater engineering margin to play with before the lubrication film failed and you had this kind of wear resulting in the whole machine failing. So this oil was probably right on the edge of what the engineers knew was required for this design, and for whatever reason this one just didn't quite make it. More than likely a little bit higher viscosity oil with a little better film strength, it would have lasted just fine. Or if the rotor to stator clearance had been a little bit wider, it might have gone a lot longer before this wear caused it to become non-functional. But the tight clearance between the rotor and stator, the air gap of the motor, that's kept very tight for energy efficiency reasons. And then the thin oil is also an energy efficiency thing. So it's clear to me in this design, energy efficiency definitely trumped mechanical reliability. So they built something to meet the standard they had to meet, and they didn't care what happened to it down the road, what it cost the customer in the end to get it repaired. They didn't care anything about that. And they obviously didn't care about the environment, because now we've got a 12-year-old refrigerator that's going to have to go to the landfill or scrapped, and it's full of foam insulation that's in the walls of it that you can't get out. It's a disposal nightmare if you're worried about that, to separate all the materials. And there's a lot of other designs they could have used that wouldn't have this finite life to it, real short life. But people as consumers have started to accept this kind of quality and this kind of short life and disposable design. So the manufacturers are to blame for making things like this, but the general public is to blame for accepting it and tolerating it and continuing to buy this kind of thing. This is what we're coming to with consumer products in this day and age. Y'all have seen me do teardowns on the GE monitor top compressors and some of the other ones that are rebuildable. And this right here is really sad. It had a short, sad life, and it made money for the manufacturer, but that's about all it did. The compressor that I put in it came out of another salvage fridge that's a little bit older than this, and that compressor is physically a lot larger for the same power, so hopefully it has a better design. So anyway, there's the seized up, not starting Embraco compressor teardown, 2009 to 2022. Such a short life. Thanks for watching.